ASOC develops multi-communication processors, which are terminal-side processors. The basic concept of the company is to have a software-defined radio programmable platform in which you can program any type of wireless, cellular, broadcast. For that matter, anything that has a modem in it can be programmed as software and run on our processors. And the other story, or the other angle of our technology, is our capability to seamlessly roam between multiple technologies which were not necessarily meant to be working together. So, for example, you can run a digital TV receiver on one side and transmit its content on Wi-Fi on the other side. You can receive a GPS signal and use it in conjunction with a cellular link and transform that data on a server. So basically, ASOC's multi-communication processors are capable of running 3 or sometimes 4 different wireless technologies at the same time. The basic reason that SDR was considered a problematic technology, especially for consumer electronics and terminals, was because it was associated with heavy penalty in power consumption. So device makers wanted to work with discrete components that were well power optimized, and the carriers just followed that track that came from the semiconductor and device makers. Carriers always saw the benefit of SDR, but they were worried about it being implemented properly. What a carrier gets from SDR are several key benefits. A, it has the capability to upgrade over the air its terminals. So today, the carriers are using device management and over the air in order to fix application problems or just simply upgrade encryption or whatever, but they don't upgrade modems yet. And with ASOC's technology, they can incrementally upgrade technologies. So in emerging technologies, such as LTE or TD-SCDMA in China, it's very beneficial for the network to be able to upgrade its terminals, which are already deployed, based on the evolution it does in its network. Another interesting example is Edge Evolution, Edge Plus, which is a terminal-based upgrade to GSM. Its major problem in being widespread is the terminal side, and ASOCS actually enables that as well. So operators are struggling with how to integrate the benefits of technologies such as Wi-Fi and broadcast into their networks. And some of them simply either try to ignore these technologies or just see them as a sort of a user-side technology rather than a network-side technology. And what ASOCS enables is the convergence of these services on the terminal side. An example in China Mobile is, for example, the use of the GSM service as a return channel to the TV broadcast. So on one side, the user is watching broadcast services from regular terrestrial TV, but on the other side, he can respond to these services through cellular. So, for example, he can vote on specific programs. He can potentially request more information on products in advertising, etc., etc. There is an additional plank which is becoming more and more popular these days. It's called 3G or cellular offloading. Networks are becoming heavily congested, with the technologies of the likes of the iPod and others, and the network has now a clear interest and benefit to offload a lot of these data to technologies such as broadcast and Wi-Fi. Again, that's a very nice implementation of ASOC's multi-communication processors. So basically, there's two end games, but they're actually the manifestation of the same technology. On one side, we envision having common platforms. That means Sony PlayStations or iPods will have a single device which will be capable of supporting all the technologies worldwide. The other aspect of it is the convergence of all these networks into a single unified service from the user perspective. Users should not care where the data or information is coming from, whether it's coming from broadcast, from wireless, from cellular, or what is the exact technology that they're using. So we see the ASOCS technologies as optimizing and making this wireless convergence transparent to users. So I know some of it sounds like science fiction, but actually technologies have matured enough to get to that point fairly quickly. There's things that need to be solved on the business model side, things which are not necessarily part of the technology. The technologies, both the SDR technologies on the modem and on the RF side, are already mature enough to enable these things to happen in the next 2 to 3 years. And we're going to see some of these things happening even next year in networks such as SoftBank or China Mobile.